So for this part, we'll be talking about section 2.2. So we'll discuss polynomials and their operations. Okay. So first, let us start with the following definition. A monomial in the variable x is an algebraic expression of the form ax raised to power k. Okay, so ax raised to power k, where a is constant, so it's a real number. We call it the numerical coefficient of the monomial. And most of the time, we'll just call it the coefficient. So we drop this word numerical. Okay? And then k here, it's an integer that is greater than or equal to 0. Okay? So the exponent that we see here, it should be greater than or equal to 0, and it must be an integer. Okay? Now, if a is not equal to 0, so if this a here, it's not equal to 0, we call k the degree of the monomial. So the degree of this expression here is equal to that exponent, provided that this coefficient is not equal to 0. So, in other words, this monomial here in one variable, it's just a product of a number or a constant multiplied to a variable, okay, that is raised to a non-negative integer. Okay? So you see this term here, literal coefficient. So this x to the k, it's also known as literal coefficient in the ancient days. Okay? But we are removing this guy here. Let's just call it the variable raised to some power, or simply the variable. So that when we say coefficient, we actually mean this numerical coefficient. Okay? The one that is attached to the or the one that is being multiplied to the variable. Okay? So a monomial, it's just a product of some number times a variable raised to some certain power. And the power must be an integer and greater than or equal to 0. So for examples, in here, you have here 3x to the 4. 3 here, it's the coefficient. So this guy here, and then the degree of this monomial, it's equal to the 4. That's equal to the exponent of x. Another guy here, you have negative 4 times x. So in here, the coefficient, it's negative 4. The degree of this monomial, it's 1. So even if you don't see the 1 there, okay, so I already mentioned this. If you have x to the power 1, you can just simply write it as x. Okay? So if you don't see the exponent, it means the exponent is actually 1. Okay? Next, we have here square root of 3x squared. Okay? So the coefficient, it's square root of 3. And the exponent, it's 2 here. So the degree of this monomial, it's equal to 2. Okay? And then here, if you just have the constant 5, this constant 5 can be written as 5x raised to 0. Okay? And this x raised to 0, we will define this to be 1. Okay? X here, it's a variable. If you raise it to power 0, we will just define it to be 1. Okay? Remember, in the last lecture, 0 raised to 0, this is undefined. Okay? So if you specifically write 0 raised to 0, that will be undefined. On the other hand, if you have a variable raised to 0, it's automatically thought of as the number 1, or it's just equal to 1. Okay? So that's why if you have this constant 5, you can write it as 5x raised to 0, which means the coefficient is 5 and the degree of the monomial is equal to 0. Okay? So if you have a constant, that's always a monomial, and the degree of that constant is equal to 0. Okay? And by that, I have to mention that the constant we're talking about, it's not your 0 number. Meaning, later you might see this guy here. You have the constant here. Of course, you can say that this is x raised to 0, or 0 times x raised to 0. Or maybe you can think of this as 0 times x raised to 1, because any number multiplied to 0, that will just give you 0. This guy here, this is also 0. Okay? And in here, this is also equal to 0 times x raised to power 2. Okay? So, if you have the constant 0, okay? If you have the constant 0, we will say that this constant has no degree as a monomial. Okay? So I will explain that further later. So for constants, non-zero constants, 1, 2, square root of 5, negative 10, negative 20, those are the non-zero constants and more. Okay? As a monomial, the degree of that is equal to 0. For the constant 0, we will say later that it has no degree. Okay? Another example here, you have negative 8x squared, coefficient it's negative 8, degree it's equal to 2. Okay? So questions so far? Now, here are some examples of expressions which are not monomials. So, for example, you have 3x raised to 1/3. Okay? This is not a monomial because this guy here, the exponent that you see here, it's not an integer. Okay? The exponent of the variable x is 1/3, which is not an integer. Therefore, this is not a monomial. Okay? Here you have 5x raised to negative 2. This is also not a monomial because of the exponent negative 2. Negative 2, it's an integer. However, we require positive integers or 0. Okay? So we require the exponent of the variable x to be greater than or equal to 0. Okay? Or if you have other variables, of course. So we need the exponent of the variable to be greater than or equal to 0 and also an integer. Okay? Questions on these examples of non-monomial expressions? Now, these monomials, okay, just like some numbers, actually all real numbers, you can add them, subtract them, multiply, and divide. So we can also do that in these monomials. So you can add or subtract monomials, provided, okay, provided they have this property. So two monomials with the same variable raised to the same power, they are called like terms. Okay? So same variable and same power, they will be called like terms. So the only difference could be the coefficients. Okay? So same power of the same variables, they will be called like terms. For example, in here, you have 3x cubed and then minus 2x cubed. So the variable is x, the power is 3. Okay? So these are like terms. Here you have 2x cubed plus 2x squared. They have the same variables, x, but the exponents are different. Here you have 3, here you have 2. So they are not like terms. In here you have 5x cubed and 3y cubed. These are not like terms. Why? Because the variables are different. Okay? Although they have the same power, okay? They are both 3. The variables are different. So like terms, same power of the same variable. Okay? So you can add or subtract only the like terms. Okay? You can combine them into a single monomial. Okay? You can add or subtract unlike terms similar to this, but you cannot simplify them. It's like you will not be able to mix them. Okay? But if you are adding or subtracting like terms, you can write them into a single monomial. So in here, for example, you have 2x to the 4 plus 5x to the 4. Okay? So variables are x, so the same variable x, the same power 4. In order to add them, all you need to do is to add the coefficients. Okay? So for this is equal to 2 plus 5 times x to the 4. So if you add 2 and 5, you'll just get 7. So that 2x to the 4 plus 5x to the 4 is equal to 7x to the 4. Okay? Another example here, you have 3x cubed plus the negative of 2x cubed. Okay? So you can just add the coefficients. But if you use this property here, this guy here, it's 3 plus negative 2 quantity x cubed. So 3 plus negative 2, that's just positive 1. And you have here 1 times x cubed or simply x cubed. Okay? Another one here, you have 2x minus 5x. So you can just subtract this, 2 minus 5, and that's equal to negative 3. And then, of course, don't forget that variable x. Okay? Now, when you do this, for example, in a quiz or an exam, you don't have to show this middle part. Okay? You can just combine 2 plus 5, that's 7. So you have 7x to the 4. Or in here, you have 3 plus negative 2, that's positive 1. So you'll just get immediately this x cubed here. Similarly for this guy here. So you don't have to show this middle part. Okay? Questions so far? Now, the sum or difference of two monomials which are unlike terms is called a binomial. Okay? So I already mentioned, you can also add other monomials which are not like terms. But you cannot mix them into a single monomial. You cannot combine them into a single monomial. So what you will get instead, if you have two unlike terms, what you will get is a binomial. Okay? So the sum or difference of three monomials, however, with three different degrees, they are called, or it is called trinomial. Okay? So this time you have three monomials, even if they have the same variables, but the exponents are different. Okay? So if you add or subtract them, you will get a trinomial. Okay? For example, this guy here, this is a binomial. You have x squared plus 1. The degree here, it's power 2. This is a constant, so this is power 0. So degrees are different, and you have two binomials here being added, you will get a binomial. In here, you have 2x squared minus 5x squared plus 3x. So as you can see, you are adding or subtracting three monomials in here. But if you look at these two guys here, you have x squared here, you have also x squared here. These two guys here, you can combine because they are like terms. And that's why this guy here can be written this way. So if you combine them, this guy here will just be this guy here. Okay? So 2x squared minus 5x squared, that's just minus 3x squared. And in here, there's still plus 3x. The x here has degree 1. Or the monomial here has degree 1. So you cannot combine this with these two guys. So you'll just copy that 3x. So if you simplify this 2x squared minus 5x squared plus 3x, you'll just get minus 3x squared plus 3x. And as you can see, the simplified version, you just have two monomials being added. So this is just a binomial. Although originally, you have three monomials being added here, two of them can be combined into a single monomial, and you will end up now with a binomial. Okay? Questions? On the other hand, you have here x cubed plus x minus 1. The degree here, it's power 3. In here, it's power 1. This guy here, it's constant, so the degree is 0. So if you add these three guys here, you cannot mix them, or any two of them, you cannot mix them into a single monomial. So there's nothing we can do in here. What we have here is a trinomial. We have three monomials which are unlike terms. Okay? And then there's also expressions where you add four unlike terms. Okay? Four monomials, unlike terms, five monomials, unlike terms. Okay? So we will call them in their general name. Okay? So the general name, it's called polynomials. Okay? So a polynomial in the variable x, this is an algebraic expression written this form. an x to the n plus an minus 1 x to the n minus 1 plus blah blah plus a1x plus a0. So this is a polynomial provided that the following conditions are satisfied. Here we have these constants, an minus 1, a1 until a0. These are constants, and they will be called coefficients of the polynomial. Okay? Now, the main condition for an expression to be a polynomial is that this exponent here, okay, must be an integer and greater than or equal to 0. Okay? So the highest exponent that you see must be an integer which is greater than or equal to 0. In fact, the exponents that you should see for the variable x must be integers that are greater than or equal to 0 only. You should not see exponent for the variable which are negative or which are not integers. Okay? So this is a polynomial. If this an here is not equal to 0, so this guy here, we call it the leading coefficient. So take note, all of these numbers, an minus 1, a1 until a0, they are called coefficients. Okay? But the coefficient of the variable with the highest exponent, okay, it will be called leading coefficient. And then this an x to the power n, so this guy here, okay, this guy here, it's called the leading term. Okay? Also, the n, so this exponent here, okay, it is called the degree of the polynomial. So the highest degree that you see in the expression, it is called the degree of the polynomial. Okay? So, in short, a polynomial is just a sum of monomials. Remember, constant, variable raised to some integer power or non-negative integer power, it's a monomial. Here, constant x raised to the power n minus 1 if n is greater than 1. This is another monomial. a1x, this is another monomial. Constants, this is another monomial. Okay? And therefore, you are just adding monomials. Okay? So, you have this. Polynomial is a sum of monomials. Okay? This means that your binomial, since it is a sum of two monomials, it's also called a polynomial. Your trinomials, they are sums of monomials also. They are also called polynomials. It's just that we use the word poly to mean, all of these things. Okay? The monomial, binomial, trinomial, they are all polynomials. Monomial, it means a single term from the word mono or from the prefix mono. Okay? Binomial, from the prefix bi, it means two. So you have two monomials being added. From the prefix tri, meaning three, you have three monomials being added. And you can go on so on. Okay? And therefore, these things, they are just special names, but they are all polynomials. Okay? So, let's look at some remarks here. Okay? So this is your polynomial. This is our convention. Okay? So in this course, we will write our polynomial most of the time in this way. You start with the leading term. Okay? You have a sub n x to the n. And then the next term is the next highest or the next higher exponent. That's why you have your x to the n. Here you have x to the n minus 1. And then the next term is the next higher, etc. Until you have written the expression with decreasing exponent of the variable. Okay? So each monomials here, each monomial here, this guy here, this guy here, this guy here, this guy here, we call them term or terms of the polynomial. So each monomial is called a term of the polynomial. If all the coefficients of a polynomial are zero, so an is 0, an minus 1 is 0, a1 is 0, a0 is 0, and everything else, we call it the zero polynomial. And as I have said, it has no degree. Okay? So let me explain why it has no degree. Your 0, again, you can write this as 0 raised to x to the 0. What does this mean? This has degree equals 0. Okay? Degree equals 0. But you can write this 0 also as 0 raised to 1. So the degree now is equal to 1. But you can write 0 as 0x raised to 2. And again, this time, this has degree equals 2. And so on and so forth. I can multiply this 0 to x raised to some integer. And the degree of that expression, quote unquote, will be the exponent integer. So the question is, what is the degree of 0? You cannot know. Okay? And therefore, we just define the zero polynomial to have no degree. Okay? So it is only the zero polynomial that has no degree. Every other polynomials, okay? Every other polynomials has its degree. Non-zero constants, okay? They are also polynomials and their degree will be 0. For example, if you have like this guy here, 5. In the previous example, this is 5x raised to 0. Of course, you cannot write this 5 as 5x raised to 1 because this 5x raised to 1, this is 5x, and they're not the same. And other constants, negative 2, this is negative 2x raised to 0, okay? And this is not the same as negative 2x raised to 1 or raised to 5, etc. So for non-zero constants, you can easily say that the degree is equal to 0. And of course, if the variable is present, okay, if the variable is present, then you can easily identify the degrees. Okay? Now, as I have said, polynomials are usually written in standard form, beginning with the leading term, the non-zero term with the highest degree, and continuing with the terms in decreasing order according to degrees. Okay? If a power of the variable is missing, it means its coefficient is 0. Okay? Later, you will see another example, but let me write an example for this bullet. Suppose you have x squared plus 1. So you don't see the variable x raised to 1 because, again, you have to write it in decreasing order of the power of x. This is written this way. This is degree 2. This is constant. So its degree is equal to 0. But where is the one with degree equals 1? It's missing in this. But that also means you have here x squared plus 0 times x raised to power 1 plus 1. Remember, this guy here, it's just 0. So if the power of the variable is missing, it means its coefficient is 0. So the coefficient of your x here, it's equal to 0. That's why it's not there. Or you can just ignore it. Or you can just not write it. Okay? Is everything clear so far? Okay. So let us look at some more examples here. You have this polynomial 3x to the 4 plus 2x cubed minus x squared plus x minus 5. As you can see, all the powers of x starting from 4 going to 0, they are all present. You have x to the 4, x cubed, x squared, x, and then x to the 0. So the coefficients, this polynomial is written in our standard form. Started from x to the 4 going to x to the 0. So we can easily write the coefficients as 3, 2, -1, +1, -5. So 3, 2, -1, +1, -5. And the highest degree here is 4. Okay, so we have degree equals 4 for this polynomial. Okay, another example here, it's -3x plus 1. So the highest power of x, it's 1. That's the degree of the polynomial. This is written in standard form. So we write the coefficients as -3, 1. In here, look at this. You have square root of 3x squared minus x cubed plus 4 plus x. If you look at the variables x, the highest power that you see, it's 3. That's why the degree of this polynomial, it's 3. This is not written in standard form. So let me just rewrite this. So in standard form, we start with the highest power. So this guy here, it's equal to -x cubed. The next higher power, it's x squared. So you have your plus cube root of x squared. And then there's also x here. So that's the next one. So plus x. And then lastly, your constant here, you have the plus 4. Okay? And written this way, you'll see the coefficients. You have -1 because of this. Then you have square root of 3. Then +1. And then +4. Okay? Questions so far? Next, here you have 2x cubed over 3 plus x. Now this guy here, 2x cubed over 3, 2 is a constant, 3 is a constant. Okay? So you can separate this 2 over 3. So this guy here can be written as 2/3 x cubed. Okay? Then of course you have the plus x. So the highest power of your variable x, that's equal to 3. That's why the degree of this polynomial here, it's 3. Now, writing in standard form, you have here, so 2/3 x cubed. And you don't see the squared part or the squared variable. It means the variable or the coefficient of that is equal to 0. Then you see your x in here. Then you don't see the constant. So you can just write that plus 0 at the end. So what does this mean? The coefficients are this 2/3, this 0, the 1, and the 0. So 2/3, 0, 1, 0. So these are the coefficients of this polynomial. Okay? Question so far? Next, you have the polynomial 5. It's just a constant. It's composed of single term. So it's a monomial also. The coefficient, it's just 5. And as mentioned earlier, the degree of this constant, it's equal to 0. Okay? By the way, in here, this example, you are adding two terms, so it's a binomial. Similarly, for this, you are actually adding two terms only. So this is a binomial. Okay? But they are, in general, called polynomials. Next example here, you have 2 minus 8x squared. Okay? And the highest power that we see here, it's squared. So the degree is 2. If we rewrite this in our standard form, you'll write it as negative 8x squared plus 2. And in here, you don't see the variable x power 1. So the coefficient of that, it's equal to 0. So if you want to write that variable x with power 1, you can rewrite this expression as negative 8x squared plus 0x plus 2. That's why the coefficients are negative 8, 0, 2. Okay? Then, the 0 polynomial, the coefficient, it's just 0. But again, this is the 0 polynomial. It has no degree. Okay?